When you look at a map of the world, there's a point where the Atlantic and Pacific Oceans almost seem to touch. The Isthmus of Panama, for centuries, that piece of land was a wall. Ships and men had to choose a very long voyage around Cape Horn, with storms and a risk of shipwreck or disembarkation, transport by land, and then back to the sea. It was slow, expensive, dangerous. Yet, right there, humanity decided to pierce the planet. Not with a tunnel, but with a navigable canal. A work that changed world trade, military strategy, and the history of an entire region. The Panama Canal wasn't born as a romantic dream. It was born of necessity. Shortening routes meant saving time, money, and power. It meant making possible what was previously almost unthinkable. Moving goods and fleets from one ocean to another in a few days, not weeks. The French tried it first, at the end of the 19th century, driven by the idea of repeating the success of the Suez Canal. But Panama was not Suez. There was no flat desert here. There were jungles, violent rains, rivers that swelled in a matter of hours, constant landslides. And above all, there was an invisible enemy. Tropical diseases, yellow fever and malaria decimated the workers. For years, they worked in inhumane conditions, with limited resources and with a fundamentally flawed idea, a canal at sea level, like the Suez Canal. In that territory, it was almost impossible, because Panama is not flat. There is a ridge of hills and rock to cut, tropical rains that swell the rivers and trigger constant landslides, and digging down to sea level would have meant an interminable, unstable, and out-of-control construction site. Costs skyrocketed, timelines dragged on, and the French enterprise collapsed. Thousands of people died. The project seemed doomed. Then the United States entered the picture. For them, it wasn't just trade. It was control of shipping routes, speed of naval movement, global influence. At the beginning of the 20th century, the United States took over the project. In those years, Panama separated from Colombia and emerged as an independent state, thanks in part to strong American interest. Soon after, the United States obtained the right to build and operate the canal in an area under its control. But having permission and the money weren't enough. They had to solve two enormous problems, nature and health. The first decisive leap was understanding that the canal shouldn't be at sea level. The winning idea was a canal with locks, like a giant water elevator. Ships would be raised to an artificial lake in the center of the isthmus, then brought back down the other side. This drastically reduced the necessary excavation and allowed the land to be exploited instead of fighting it every inch. The second leap was the fight against disease. Here comes in one of the most important and often underestimated parts of this story, sanitary engineering. The Americans launched a massive campaign against mosquitoes and outbreaks, with drainage, reclamation, disinfestations, nets, and controls. Today it seems obvious, but back then it wasn't. Reducing yellow fever and malaria wasn't just a medical success, it was a condition for building the canal. Without that breakthrough, the workforce would have continued to die at an unsustainable rate, and no construction site would have held up. At that point, the hardest phase began, the one that defined the Panama Canal as we know it. Imagine what it means to cut through a chain of hills in a tropical climate, with rains turning everything to mud. The symbolic point of this battle is the Great Cut in the Rock, today called the Culebra Cut or Galliard Cut. It's a huge trench dug between unstable slopes. Explosives, excavators, mechanical shovels, and above all, trains were used every day. The trains were the construction site's circulation system. They carried away millions of cubic meters of material, non-stop, but the slopes continually collapsed. They dug, they cleared, and the mountain came back down. It was a repetitive, exhausting battle, costing time and lives. Imagine being here, in the middle of the Panamanian jungle. Everywhere there are noises, shadows, and something you can't see but that's watching you. The same thing happens online. Trackers, public Wi-Fi networks, data theft attempts. That's why I use NordVPN. It creates an encrypted tunnel between you and the internet, so you can browse with more privacy and security, even when you're traveling or on unprotected Wi-Fi. If you'd like to try it, you'll find the link in the description. Then there was the water. Panama wasn't just land to be dug, water to be tamed. The local rivers, especially the Chagres, were unpredictable. During the rainy season, they could become devastating. The solution was a gigantic idea. Create a huge dam and create an artificial lake. Lake Gatun. It wasn't just a reservoir. It was part of the canal itself. Essentially, a central section of the canal was a navigable lake. This turned a problem into a resource. The lake helped control floods and provided the water needed to operate the locks, because locks work by consuming water. Every time a ship ascends or descends, enormous chambers fill or empty. The water enters by gravity, without pumps. Simple in principle, but enormous in scale. A ship enters a chamber, the door closes. Water is let in or out through pipes and valves. The ship slowly rises or falls, remaining stable. Then the next door opens and the ship passes into the next chamber. It's a sequence, a real elevator, but made of water. The total height difference is about 26 meters. It doesn't seem like much until you see it applied to a loaded ship, hundreds of meters long. Precision was everything. A ship cannot go off course inside a narrow chamber. For a long time, To aid passage, rail locomotives, commonly called mulas, were used, which guided and kept the ship centered with cables. Today, management has changed somewhat, but the concept remains: millimetric control, because the spaces are designed to the limit. And here we understand why this work has had such a huge impact. It's not just a canal, it's a complex industrial system, where water, gravity, engineering, and logistics work together. When the Panama Canal was completed and opened to traffic in 1914, the world truly changed. Routes between the east and west coasts of the Americas shortened dramatically. Goods between Asia and the Atlantic found a more direct passage. Ports, shipping lines, supply chains, everything adapted to this new global shortcut. But the canal has never been a static object. It has always had a limit: the size of the ships it can accommodate. For decades there was talk of Panamax ships, designed to pass exactly through the original locks. Then, with the growth of trade and ever larger container ships, a new phase arrived: expansion with new, larger locks, which came into operation in 2016. This allowed the transit of much larger capacity ships, often called Neo-Panamax. In essence, the canal was updated to avoid becoming obsolete. Yet, even today, the canal exists in a delicate balance. Its true fuel is fresh water. Without enough rainfall, without sufficient reserves in the lake, the number of transits can decline. Every passage consumes water that then ends up in the sea. This is why water management is centralized. And this is why the canal is also a thermometer. If rainfall changes, if climate cycles change, the rules of the game change. There is another aspect that is often overlooked. The Panama Canal is not just a technical feat, a geopolitical pressure point. Whoever controls that passage controls times, costs, and flows. For much of the 20th century, the canal was managed by the United States. Then, in a long transition sanctioned by international agreements, control passed to Panama in 1999. Since then, the canal has been managed by the Panama Canal Authority and has become one of the country's economic pillars. First, there was a land wall between two oceans. Then man built a navigable corridor with dams, artificial lakes, gigantic locks, and colossal excavations. But the price has been enormous, not just in money, in human lives, effort, accidents, and illnesses. The Panama Canal is also a story of extreme work, of engineering pushed to the limit, of decisions made under pressure, in an unforgiving environment. And how does it work today? A ship is booked and programmed. It enters from an ocean, attaches itself to the guidance system. It passes through the locks that lift it. It navigates the lake and the excavated sections. Then it descends through the locks on the other side and returns to the sea, all in a passage that, for a ship, can take several hours, but for world trade, means days saved on each voyage. The Panama Canal is an artificial wound on Earth, but also one of the most concrete examples of what happens when a species decides that an obstacle will no longer be an obstacle. It was built where it seemed impossible, paid for at an enormous human cost, and transformed into a machine that shifts the weight of the planet every day. Two oceans separated by nature, united by a choice. And that choice, even today, decides who arrives first, who pays less, who dominates the routes. If you enjoyed this journey through the Panama Canal, subscribe to the channel. Here you'll find new incredible stories, told in a simple and engaging way.